This meter is a triplet meter, and it has to be zeroed every time you turn it on, and it wanders a little bit, just so you know. The best, sometimes it's hard to get right on zero. It's best you can do is about either minus 0.1 or plus 0.1, and attempting to zero it. Okay. Now, what we have here, that's going to be close enough. It's going to 0.1. What we have here is an alternative energy device that will produce electricity from space. Basically, this work was pioneered by John Keeley and Nikola Tesla and Henry Moray and Lester Hendershot and a number of others. But Keeley left behind the information that says that if you match harmonic electricity to inharmonic electricity, you will tap the dominant, which is basically unlimited. Modern quantum physics tells us that there's 200 megawatts in every cubic foot of space. That's not counting the matter that can be converted into energy also. What that's talking about is there's positrons and electrons, and the two have, one has a positive charge, one has a negative charge. Electron is negative and the positive is a positron. These are attracted to each other because of their charges, just like if you rub your hair on a balloon and it sticks to the ceiling. They attract each other, they set up an orbit around each other, they appear to cancel out from our point of view. But they do not cancel out. That's just a mirage. There's billions and trillions and more than that in every cubic foot of space. These things are splittable, and when you split them and separate them, you can run them back through a circuit and have usable electricity. And that's basically what we're doing here. The output here is DC. This is a DC meter. It's reading 0.1 negative. We're going to put some different loads on this. I'm going to let you look at this thing all the way around. There's no wires on it at all. Basically, it's just a device there, a generator, but not a standard electromagnetic generator. We have two ground plates. We have the Hemisphere. There's a number of different devices in here. There's a toroid. There's the output. It's nice and simple. These can be built any size. They're not fully developed. If they were fully developed, we'd be selling them to people. There's still some more components that need to be developed for continuous use and for heavy loads, which is what you'd have like if you ran a car or a house with it. Okay, now I'm gonna clamp the amp meter in here, and we're going to hook some loads to it, and I'm going to make sure that we're focused in on the meter reading. Hopefully we'll be able to see it this time around. I'm going to zoom in, get it centered, and back it up a little. Let's see if I can zoom in and get that in. Okay, you can see the reading. I guess I'll have to zoom in several times or something. Anyway, our first load here is a standard electrical light. They sell these at Sears. Bought this many years ago. Hopefully you can see what it is here. I'll set the bulb back here. I'll plug it in the front, and you see it lit up. Now what's interesting is it lights up and then it gradually draws back to its normal load conditions, and it's reading 3.6 amps. It'll probably adjust down to 3.5, maybe up to 3.7, I don't know. But anyway, hopefully you can read it on the thing. Yeah, you can. 3.7, it went up. If it was a regular battery, it'd be going down instead of up. Just so that helps prove something. It's going between 6 and 7. It goes up instead of down. That proves it's not a regular battery. that's hidden inside the circuit. It's not a regular battery hidden inside the circuit, otherwise the amperage would be going down, not up. Also, this thing gets brighter and then dimmer. That's not a typical, well, it can be, but it depends on the system. But anyway, generally speaking, it's not typical. Here we have another one. Okay, 1.8, 1.9. You see it went up instead of down? It's going back to 1.8, but if it was a battery hidden in the circuit somewhere, it would be getting lower and lower and lower rather than higher. 1.9 again. And that just shows you how that works. And then we're going to run a motor. Puts out a bit of torque. By the way, all the output here is DC. Okay, it's reading pretty close to zero. The problem is I don't think it's zeroed. This meter wanders a little bit, so it's reading minus almost 0.2, really, minus 0.2. So, and it goes up to zero, so that means it's really positive 2 that we're drawing here. Just so you know. Well, that shows basically that the thing works. We can run it as long as you want. And it'll still be drawing positive 0.2. We may have to reset the thing to zero a few times. We'll do that, I guess. We'll run it for a minute or two. And while I'm doing that, I'll talk to you about the way this works. Most people would like to know. Basically, like I said, the positrons and electrons can be separated. They actually will repel each other when you hit them correctly with the right kind of mixture of energies. You gotta have the harmonic and the enharmonic. You gotta have both, and you mix them correctly. They will repel each other, and that's all you need to capture them in a battery or a capacitor. Just a brief second of repulsion, a brief split second. Actually, it's in the microseconds of repulsion. So they split. You capture them, and then you run it through a circuit. You got electricity. Traditional systems do this all the time. This is actually so strong that if I try to stop it, it'll take my skin right off. And we're just drawing almost nothing, but of course it goes up when you load it. See, 2.3 amps. It has to. That's the way motors work. Anyway, this stuff, yeah, basically there's 4 different types of shapes that will produce enharmonic energy. You have to match the harmonic to the enharmonic by thirds. You got the sphere, the hemisphere, the pyramid, and the cylinder. The best is the hemisphere, second best is, the best is the sphere, second best is hemisphere, third best is pyramid, and fourth best is the cylinder. And your wire itself can be used to make these shapes. The shapes aren't necessary. You'll have to use one of them no matter what if you're going to make a free electricity energy. Of course, a coil wire is basically a cylinder, depending on how it's wound, but it can easily be a cylinder. We really need to get behind this. People need to get behind this. This is not going to happen if people don't get behind it. Much information available nowadays that we are destroying the planet with carbon compounds due to fossil fuels, which is what all the electricity is made of now and made by now, is fossil fuels. And plus our internal combustion engines from our automobiles and all that. We need to get off fossil fuels if this planet's going to survive. It'll be history for all life on this planet as we know it. Plants will die, animals will die, people will die. So we need to get behind this technology. We need to get this stuff out. Everybody can use this stuff. It needs to be properly developed. It needs to be marketed, and it will take the place of everything we got now. I believe we can do it. Best wishes to everybody.